inscribed angles, which have a vertex on the circle. So the vertex is no longer on the center, the vertex is on the circle, and the two sides are not radii, the two sides are chords. Okay, so when we look at that diagram, ABC is an inscribed angle because its vertex B is on the circle. So angle ABC is what we consider an inscribed angle. An intercepted arc is the arc that lies between the sides of an inscribed angle. So I like to really extend those lines outside of my circle because they really do, they cut off that arc. It's very clear that the intercepted arc here is arc, the minor arc AC. Okay, if you extend the sides of the angle, the intercepted arc is between those two sides. Now, for a central angle, it was equal to the arc, right? Angle was equal to the arc. For an inscribed angle, it is half. The inscribed angle is half the measure of its intercepted arc. So over there below the picture where it says the measure of angle ABC, that is equal to 1/2 the measure of arc AC. So say, for example, arc AC is 80, then the angle is 40. Or vice versa. If you know the angle is 40, then you multiply it by 2 to get the arc is 80. Now, the next two things, we're going to go over them, but it's not really, it's not like you have to memorize this. You do have to memorize and learn that the inscribed angle is half the measure of the arc. But the next part, it's just, if you remember it, great. If not, you can still figure it out. If an inscribed angle intercepts a diameter, so what we're talking about is angle BAC here is the inscribed angle. Notice that it cuts you've got the diameter right there, so its arc is half the circle. So if that's 180, because it's half the circle, then the angle is half that, so it's a right angle. BAC is 90 degrees. So if the diameter touches the edges of your inscribed angle, then that inscribed angle is always going to be 90. But again, you can still figure it out. I mean, just looking at the diagram based on what we know, that diameter cuts it in half, so we've got 180 right here. The angle is half of 180, so the angle is 90. Okay, overlapping arcs. If two inscribed angles intercept the same arc, then the angles are, what do you think is going to go in that blank? If they intercept the same arc, are they going to be different? They're going to be the same? Probably, well, let's look at it. What it's talking about here is ABD. There's an inscribed angle. If you extend the sides of that angle, the intercepted arc is AB. Well, we have another inscribed angle, ACD. If we extend those sides, guess what arc it intercepts? The same arc. So the angles must be congruent. They're the same. So the measure of angle ABD is equal to the measure of angle ACD. They intercept the same arc, and the angles must be congruent. Kind of one of those that makes sense statements, hopefully. Let's look at some examples. Number 1. We need to find the measure of angle WXY. So trace it out, extend the sides, trace out the arc in between the sides. That arc is labeled with 62. 1/2 times the arc equals the angle. 1/2 of 62 is 31. So that angle is 31 degrees. Number 2, the measure of arc DGF. Okay, so this time they give us the arc, or well, they're asking us about the arc. So trace out that arc. Look at what angle creates that arc. That's the 113-degree angle. So 2 times the angle equals the arc. Let me go back to number 1 and write that 1/2 times the arc equals the angle. So 2 times 113, 226. These are all either angles or arcs, so they all have degree measure. Okay, number 3. Number 3 wants the angle PQR, so trace it out. P to Q to R. That intercepts this arc, which is half of our circle. Because of that diameter, it's half the circle, so 1/2 times the arc equals the angle. 1/2 times 180 is 90 degrees. Okay, this is that intercepting a diameter property up here. Technically, we could have just jumped to that. We didn't have to do the work. But I did the work to show you that as long as you take what we've been doing and add what we learned today, you can figure it out. You don't have to memorize that property. Number 4 wants the arc BC. We want the arc BC. Now here's the problem with BC. BC is not intercepted by the angle that is drawn. So this is the case where we're going to have to do a little extra legwork. So let's look at what that angle does intercept. That 47-degree angle intercepts from A to C. So if we multiply that by 2, we get 94. That's the angle from A to C. We want the angle from B to C. Well, is that not a diameter from A to B? So 180 minus 94 is going to give us what we need. So 86 degrees. Again, there's no magic formula. I can't tell you step by step what you're going to do every time. You're going to have to just play around with some of these. Number 5, the measure of angle JKL. J to K to L. What will help you the most, though, is drawing on these pictures. Don't try and do it without drawing and tracing out what they want, what you're given, etc. Angle JKL is what we are wanting. That intercepts this arc right here, a good portion of our circle. So what are we given? We're given 53 and 65. If we take those away from 360, we're going to have that big arc that I traced out. So 242 is that whole side of the circle. We wanted the arc, the angle. We wanted the angle. That's the arc. So half of the arc equals the angle. That's an angle symbol right there. That's not meant to be a number. So 121. 121 degrees. Let's look back at number 2 for just a second. I forgot to mention something as far as just doing a little common sense checking here. On number 2, if you had mistakenly forgotten that an inscribed angle is half the arc, if you had just said, well, that arc is also 113, does that even make sense? Look at the picture. Okay, sometimes they're deceiving, but most of the time they're fairly accurate. That arc is way more than half of the circle, so it's definitely got to be at least 180, right? So if you have multiple choice answer choices, you definitely should not pick one of them that's less than 180. So 113 is out. They're definitely not equal. You got to multiply the angle by 2 to get your arc. Okay, back to number 6. Number 6. Angle RST. 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 So that intercepts this arc right here. It's not labeled, but every other part of the circle is. So let's take those away from 360. 64 plus 131, 75. We get that we've got 82 degrees left for that piece. The angle is half of that. So it's 41. Okay. Angle RUT. RUT, different angle, however, it intercepts the same arc, so it has the same measure. Its arc is 82, so 82 divided by 2 is still 41. It did not change. Question so far before we put a letter in there? Okay, number 7. Solve for x. We've got the angle is labeled as 8x minus 9. Let's trace it out and make sure, I mean, most of the time these are going to match up, but not all the time. Trace out that angle. It intercepts this arc. So there are 2 ways of looking at this. Either 1/2 times the arc equals the angle, or 2 times the angle equals the arc. It's the same relationship. I'm just moving where that number is. Now, there's technically nothing wrong with doing 1/2 times the arc, but that's a fraction, and sometimes these numbers are not going to be evenly divisible by 2, so let's not deal with that. It's a whole lot easier just to multiply by 2, right? 2 times the angle, 2 times 8x minus 9 is equal to the arc. We can work that out. 16x minus 18. Make sure that you remember to distribute. Add 18 to both sides. 16x is equal to 176. Divide by 16. X is 11. Solve for x. We are finished. Now, if you really want to be thorough, check it. Plug it in. 8 times 11 minus 9, we get 79. If we multiply that by 2, we should get the angle, or the arc, excuse me, get the arc of 158. Okay, number 8, same deal, solve for x. Let's look at what we've got. We have this angle. It intercepts the arc that's labeled, so 2 times the angle equals the arc. 2 times the angle equals the arc. So that's 134 is equal to 4x plus 58. Take away the 58. 76 equal to 4x. Divide by 4. 19. Solve for x, that's all we had to do. So we are finished. X is 19.